बोल रहे हैं मेरे पास बहुत इश्यू है एनी टाइम मैं मोबाइल विल गेट नो क्लास
Hi, hello everyone. Good evening. Hope you all good with best of your health. Am I audible, right? Let me know through the chat box. My screen is visible and I'm an audible to all of you. Okay, yes, cool. Then it's fine. Do it and to record. Once again, welcome to all of you guys. This is Shyam. Today we are going to talking about the wave optics में और एक अलग topic है इधर, that is Doppler effect. And as well as before starting the Doppler effect, what are the things we discussed in yesterday class? We are going to take a quick recap. Okay. Okay, sorry for the disturbance, guys. Okay, we'll study about today Doppler effect. Before that, what are the things we discussed in a previous class? No, let us take a quick recap. Okay. In last class, क्या किया थे हम? Diffraction of light. Correct है ना? Just a minute, just a minute. Yes. Diffraction of light. ये diffraction of light क्या होता है? I told you that bending of light around an obstacle we call the diffraction of light. Yesterday we discussed about the Fraunhofer diffraction. Correct now? Fraunhofer diffraction we studied. How we studied experimental arrangement. I told you that if you are going to take this as source of light will be emerged as the spherical wavefront. When the spherical wavefront will be incident on the lens, okay, the after emerging out from the lens, this will become parallel. Plane wavefront hota hai, right? Here also diffraction condition में क्या लियाते हैं हम? The slit width है ना, ये भी ये value it should be equal or less than or equal to the value of lambda. Wavelength के साथ equal होना चाहिए. Correct ना? Then after diffraction क्या होता है? This all the rays will be come in this direction. They will be incident on a screen where I kept the screen at a distance d. Correct na? But we can't able to analyze the diffraction pattern properly. For that reason, what I did, again I introduced one more lens here. When I introduce this one more lens, these rays are converging at this point. Here we will get a bright fringe. Why we got a bright fringe means here from the particle from A to B. I told you if you're going to consider here 100 particle are there means 100 particles का path length क्या होता है इधर 0 होता है. Path difference क्या होता है इधर 0. Correct ना? Each and every particle of this wave travel the same distance, right? That's why path difference will become 0, right? Okay, what if about upper side and as well as downer side of the fringes will be formed? No, is they having the same intensity? No, diffraction pattern will be changes here. Correct na? Intensity also continuously goes on decreases. Yesterday I told you. Okay, if you consider a point, this is a central bright fringe at some other point P, what will be the fringe will be formed here? What kind of fringe will be formed here? It's a dark fringe or bright fringe. To know that one, we took the path difference first. Kitna lambda le liya tha. Correct now? When we take the path difference lambda, right? Actually, at that condition lambda mein, all the waves which they are making destructive interference. Correct now? That's why at this point you will get a dark fringe. Correct now? Then if you're going to take the 2 lambda, again it will be destructive interference, and 3 lambda, again destructive interference. Like that, generally we write this one as an n lambda. Means in this condition, diffraction may n lambda or lambda, 2 lambda, 3 lambda. Like this path difference are there, means it is constituting the dark fringe. Correct? But it is exactly opposite to the interference of light. Interference of light में n lambda means like this quantity को bright fringe बनाता था, but इधर नहीं है. Correct ना? And then the bright fringe bright fringe formation करने के लिए path difference कौन सी था? Delta x will be 3 lambda by 2, and then 5 lambda by 2, 7 lambda by 2, like that up to 2n plus 1 lambda by 2. This is what the general condition for the bright fringe. Correct ना? Means lambda होता तो dark fringe होता है path difference, 3 lambda by 2 होता तो it will makes the bright fringe. Correct? बोलो सही है क्या नहीं है? क्या होता है? Already I told you central bright fringe का will be formed. One means lambda by 2. It's a path difference, means here we will going to divide this one 3 segment. This 3 a by 3 वाला wave fronts का सेट होता है ना, इस सभी की सभी wave front इधर कैंसल होता है. Correct ना? Remaining a by 3 reach the point here. Means intensity will be decreases by amplitude by 3 times. Correct ना? Actually हमको पता है हम intensity will be directly proportional to the square of the amplitude. इधर कितना बार कम हो रहा है? Only a by 3 portion is coming, means 1 by 3 times coming less हो रहा है, means a square by 9 हो गया. Intensity 9 times decreases. Further here another intensity spot will be मिलता है ना, इसका कितना होता है? Next 3 by 2 over 5 by 2, 5 lambda by 2. Correct ना? Path difference कितना होता है उधर? 1 by 5th of the particle will be reached, means a square by 5th square means 5 square means 25 होता है, means 1 by 25th time इधर second point में intensity decrease होता है. Similarly down भी 0.1 by a square by 9 होता है, 0.2 पर a square by 25, a square by 49. Like this intensity continuously decrease होता रहता है. But whereas in our interference of light, intensity not decreases continuously. Intensity will be same for all the bright fringes. Correct now? Okay. Then we talk about the graph also. Correct? Graph में intensity था y-axis में, x-axis में path difference लिया था हम. Path difference. Correct now? When path difference is 0, the intensity of the light will be maximum. Intensity will be maximum. So not lambda, I naught. Okay, when path difference will be lambda means either side intensity decreases like this, दोनों side में. Correct ना? And when it is a lambda, this is 2 lambda means again here intensity is 0. In between these two, 3 lambda by 2 will come, means intensity थोड़ा ज़्यादा होता है comparatively. Correct ना? Next, इधर 3 lambda means in between this one 5 lambda by 2 होता है, intensity again decreases. In this side also same happen. Correct ना? This is what the intensity and as well as path reference graph. Right? This is what all about we discussed in our last class, guys. And here path reference for dark fringe क्या होता है? Keep this in your mind. It is very important. Actually, ये sin theta is equal to n lambda we will write. Right now this is the path difference. This is for dark fringe. Dark fringe in diffraction. Similarly, a sin theta is equal to 2n plus 1 lambda by 2 means it is bright fringe. Okay. Okay, guys, this is all about yesterday class, and we calculated the fringe width also. Dark fringe width के लिए एक फॉर्मूला भी बनाए थे हम. क्या था वो? 2 times 3 d lambda upon small d, or else if you're going to take your a means it will be a. Correct now? This is what the width of bright fringe. Clear? And be careful about the fringe width. Okay. Okay, next thing क्या है देखते हैं आज के क्लास में. Fresnel diffraction. Okay, actually up to now we discussed about the Fraunhofer. This is a Fresnel diffraction. Fresnel diffraction क्या है ना, is separation distance है there, no? Separation distance, it is very small. Last time we taken a d means it is very large one. Correct now? This time we are going to take very smaller one. Actually, Fresnel is a scientist. He analyzes the diffraction pattern with a very small distance. Correct now? That's why he given an equation also for to calculate this one. Equation क्या है ना? Same ही, कुछ भी नहीं change होता है. इधर change होने का टर्म्स है ना, उसको लिखते हैं मैंने. फर्स्ट क्या था? पाथ डिफरेंस था. राइट ना? पाथ डिफरेंस वैल्यू कितना आया था हमको? ये sin theta is equal to n lambda for the dark fringe आया था. If you want to consider the sin theta as an theta for a small angles, then a theta is equal to n lambda आता है. Right? Theta value will become n lambda by a आता है. Correct now? Right? What I'm saying? This is a Fresnel diffraction now. Right? This is a path difference what we took, and this is a theta angle which is making. Right? Either. So what you will take? No, you will take the distance as in z. Okay, this z distance है ना, the z distance almost all equal to the lambda by a होता है. Lambda by a के लिए equal होता है इनके तरफ से. What are you understanding what I'm saying? This is the distance what it is traveling. Here n means n को multiply कर दो. Correct ना? Or is equal or less than. Equation देखो एक बार. Sorry. It's a path. Sorry, it's by mistake. It is by mistake. By my mistake. इधर देखो. That is the path which is traveled by the light according to the Fresnel. Okay, here the value is there, no, the value of a by lambda. So lambda by a, n का छोड़ दो, n value means 1 means it will become lambda by a है ना, ये equal होता है किसके लिए? Lambda by a, no, the traveling distance is z means z lambda by a is exactly equal to the slit width. कितना थोड़ा सा जगह में find out the diffraction pattern. Okay, here we need to find out the value of z. Z means it's a Fresnel diffraction distance. Z value क्या होता है इधर? A square by lambda होता है. This is one of the equation actually given. It is given by the Fresnel. Keep this in your mind. I think it will not come to the exam also. Cool. Okay. Next क्या है? Yes, resolving power. Try to understand this point. So resolving power क्या है? Actually, when इधर pattern बन रहा था ना, diffraction pattern. देखो, this is a slit. This is one of the slit. तो नहीं अच्छा बन रहा है. This is a slit. Okay. इन slit में क्या हो रहा है? Wave front incident हो रहा है. Okay, this is the wavefront AB. Okay, after then this all the wavefronts will be bent and will be travel like this. Means इधर क्या बनता था डिफ्रैक्शन में, डिफ्रैक्शन पैटर्न बनता था, करेक्ट ना। ये पैटर्न को एनालाइज करने के लिए क्या किया था, हम एक कॉन्वेक्स लेंस यूज किया था, मालूम है ना, कॉन्वेक्स लेंस, बिकॉज इट विल कन्वर्ज ऑल द रेज हियर एंड वी कैन इजीली आइडेंटिफाई। सिंपल है, यही सिंपल कॉन्सेप्ट। ये रिजॉल्विंग पावर है मींस if these are the two closely lying particles, they are very closely lying particles. Okay, आपका बायोलॉजी में होता है ना पार्टिकल्स, these are the two closely lying particles. इसको क्या करना है, हमको सेपरेट सेपरेट करके देखना है, right? At this situation we are using the diffraction phenomena, right? By using the diffraction phenomena, we developed one instrument, we called that one as an microscope, right? Microscope में क्या होता है, one particular point को, तो closely lying particles को we can visualize like a separated. Okay, that is known as the resolving of the particle. उसका power depend होता है लेंस के ऊपर. Okay, how much the lens will be resolve the two closely packed particles to exact extent. Okay, that is known as the resolving power. Correct ना? देखो इधर फर्स्ट वन है, इसके ऊपर इसके अंदर टू पार्टिकल्स आते हैं, they are actually completely overlap with each other. इसको रिजॉल्व करना है ना, when you view through the microscope, I will explain how it will be. Okay, there first they will become, this is the second stage they given, just resolved, this is the fully resolved, means completely we can visualize this one like this, right? This is the resolving concept. Coming to the power of resolving power of a microscope, इधर देखो ये पॉइंट भी है ना, इधर ऑब्जेक्ट रखता है, ओके, ये ऑब्जेक्ट रख के इधर से हम देखते हैं, राइट, इधर से देखते हैं. Here this distance d is there, no, based on this distance from this point से क्या होता है, light will be emerging in both the direction, then we can analyze these rays which are actually diverging, correct na, these are the diverging rays. When they are incident on the lens, they will be become parallel, correct. And if you're going to keep it downward and upward motion करने से क्या होता है, वो we can easily resolve the closely lying particles को ऐसे देख सकता है. ओके, इधर तो फॉर्मूला दे दूंगा कैसे करता है वगैरह वगैरह. ओके, इधर दिस रिजॉल्विंग पावर, एक्चुअली दिस रिजॉल्विंग पावर is actually inversely proportional to the distance d. Okay, ये distance ज्यादा होता तो they are actually coming to the closer, they will see is like a 1. Kab the distance of the eye lens to the particle. Okay, if distance will be become closer, it will be the lens is moving downward, means this particle will be start to separate like this. That's why if the distance is more means resolving power come, if the distance is come means resolving power will be higher. And this resolving power कौन सी चीजों में depend होता है. First thing है, resolving power will be depending on the wavelength of light, which color of wave you are using. Next one, resolving power is proportional to the cone angle. Cone angle कौन सा है, देखो इधर ये लेंस है, लेंस के ऊपर लाइट आ रहा है ना, from the particle those who are actually closely light, correct, this is called the cone angle. ये थीटा होता है, ये भी थीटा होता है, correct ना, right, what I am saying. ओके, छोड़ दो, कोई बात नहीं. नेक्स्ट, इधर दो थीटा है, मींस हियर फर्स्ट वन रिजॉल्विंग पावर इनवर्सली प्रोपोर्शनल टू d. नो, d can be written as here d, how we can written the value of d, will be proportional to the lambda first one. Correct now? And as well as d is proportional to the 1 by 2 theta also. Angle. Two angles आता है इधर इसलिए. Right? Then resolving power, it will be equal to 1 by lambda times now. Sorry, something is missing now. Mistake हो रहा है इधर. देखो इधर. Yes, sorry. Resolving power है ना 1 by cone, 1 by times the cone angle को equal होता है. 1 by times the cone angle को equal होता है. Then resolving power will be equal to lambda divided by 2 theta होता है. Right? And then a theta को we can write as an sin theta also. Then resolving power होता है lambda by 2 sin theta. We can write like this also, there is no problem. Okay, what if you're going to introduce any medium in between them? In between them here, if you're going to introduce any glass media or water medium, means refractive index आता है. उस समय में क्या करना है? Again, resolving power will be equal to lambda by 2 times mu sin theta. Mu को multiply करना है optical part को. Clear? Clear. And direct formula I will give for the microscope. Microscope के लिए resolving power होता है resolving power of a microscope. Resolving power of a microscope will be equal to 1 divided by d theta. Will write it's a d theta. D theta means it's the angle where you are going to visualize. Okay, d theta value will be equal to 1.22 times the lambda divided by d. Okay, use this formula for the resolving power of a telescope. Cool. So next thing, it is not very interesting and as well as main topic for the examination. Doppler effect. Doppler effect basically क्या होता है? सुनो, Doppler effect को explain कर रहा हूँ मैं. This is not the concept. Okay, the concept is that Doppler effect. Doppler effect. Imagine कर लो, इधर एक बस स्टैंड है. ये क्या है? बस स्टैंड. आप इधर खड़े हैं. ओके, आपके in front of you there is a road. Okay, then it's a very long road. You're going to see towards this side. Okay, at the time bus, you can visualize a vehicle which is coming. Bus is coming means approaching towards you. When it is approaching towards you, इसके पास क्या होता है? Sound होता है. In terms of sound, I'm explaining you guys. Sound होता है. Sound क्या करता है? When bus is far away from you, okay, sound आपको come means less amount of sound will be visual. You can hear the sound very less amount. Okay, when it is very far away from your point. As the bus approaching towards you, sound क्या होता है? Increase होता है intensity of the sound. Then is it the meaning of when the bus approaching towards you, it is making more sound? No. The sound of the bus which is emerging from the vehicle, it is same at all the point. But here one of the effect you are going to observe that when some bus will be very far away means you will visualize sound is less. When it is approaching towards you, it is the sound value क्या हो रहा है? Every point increase हो रहा है. When it is coming near your point, here sound value क्या होता है? बहुत ज्यादा होता है, maximum होता है. Correct ना? Here maximum. After then, bus to the stop नहीं होता है. It will be start to move further away in this direction. as it is moving away from the your point, again sound value क्या हो रहा है, decrease हो रहा है, decrease हो रहा है, decrease हो रहा है. At one certain point the complete amount of sound will be decreases. This is called the Doppler effect of sound. Doppler effect क्या बोलता है, means intensity of a sound will be increases when it is reaching or approaching towards the person or observer, right? But when the bus will be moving away from the person means or observer means, again the sound intensity will be decreases. This is the effect we call Doppler effect. Same thing we need to analyze this one for the light. Light के लिए analyze करना है. कैसे analyze करता है, देखो इधर एक बार, देखो 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 मेका सुपर. देखो ये है सोर्स ऑफ लाइट. ये क्या है, सोर्स ऑफ लाइट. सोर्स ऑफ लाइट मींस इट विल emit the source in all the direction. Either it is emitting the light in the form of wave like this, correct ना. Two members are observers are there. Just imagine like that. Source is fixed one. Now source is fixed one. First observe यही है कि मैं हूँ, ओके, इधर खड़ा है मैंने. Actually what I will do now, source fix है, I will move away from the source. पीछे 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 जा रहा हूँ, ओके. At that time मुझे source of light, source means it will be coming white light, all the lights are present, right now. When I'm moving away from the source of light, the wavelength, actually उधर sound में क्या हो गया था, sound intensity decrease हुआ था, करेक्ट ना. इधर वेवलेंथ इंक्रीज होता है. वेवलेंथ क्या होता है, इंक्रीज होता है वेवलेंथ. एंड फ्रीक्वेंसी क्या होता है, डिक्रीज होता है. as I move away from the source, move away from the source, क्या होता है, wavelength increase होता है, frequency decrease होता है. Like this, when I moving away means this white color source है ना, it will be looking like a red color. मुझे कैसे दिखता है, red color. Okay. Now second scenario देखो देखो, if I am going to move towards the source, if I move towards source of light, okay, when I am moving towards the source of light, this wavelength होता है ना, it will become less. Okay, less होता जाता means intensity जास्ती हो, intensity will be increases and frequency also increases here. When the frequency increases, at the time the same wave of the source, it will looking like a blue, right? These are two things which are happening. Sound में क्या होता था, a bus which is approaching towards a man, vehicle which is approaching towards a man, sound intensity increases. At this point sound is maximum. When it is moving away from the person means again sound क्या होता था, decrease होता था. Similarly here source fixed one है, इधर person क्या है, observer. If he is moving towards the source, okay, the source of light which is looking like a blue, okay. If you move away from the source of light means it will look like a red. Okay, this topic or effect we call the Doppler effect in a light. और एक बार बता दूंगा कैसे सब कुछ होता है. देखो इधर ये व्हाइट लाइट है, व्हाइट लाइट, ओके. व्हाइट लाइट से क्या हो रहा है, wavelengths are coming, waves are coming. If you are observing from this point means, okay, just imagine that now you are fixed now, okay. Now in case this source of light which is moving away from the point, this is a source now moving away from the point means ये दोनों के बीच में होता है ना डिस्टेंस लैम्डा, वो क्या होता है, लैम्डा इज इंक्रीजिंग. कब तक इंक्रीज होता है, लास्ट वेवलेंथ का लैम्डा कितना होता है, मैक्सिमम मींस रेड कलर मीन्स सोर्स इज मूविंग अवे फ्रॉम यू मीन्स लैम्डा क्या हो रहा है, इंक्रीज हो रहा है. फ्रीक्वेंसी क्या होता है, डिक्रीज होता है. फ्रीक्वेंसी विल बी डिक्रीजेस. करेक्ट ना. मान लो इस सोर्स है ना, सोर्स के पास में होता है ना फ्रीक्वेंसी, वो न्यू है. सोर्स के पास है ना फ्रीक्वेंसी, वो न्यू है. Okay, when it is start to move away from the person, sorry, away from this person, fixed person, this lambda is increasing. That time this person will feel the frequency of light is different. I'm going to call that one as a new dash. Frequency obviously increase hota hai na. Wavelength, sorry, wavelength increases means frequency क्या हो रहा है, sorry, decrease हो रहा है ना. Okay, if frequency is decreasing means here क्या हो रहा है, change in frequency takes place हो रहा है. Correct है ना what I'm saying? Frequency is changing. That condition, in this condition exactly, the source actually it is exhibiting white light only, but the person who is seeing this one, no, he might see this white light as an red color, right? We call this one as an red shift. Red shift बोलते हैं इसको. कब बोलते हैं red shift means source of light it should be moved away from the person, or else the person should be moved away from the source of light, right? We call red shift. Correct now. Second case, source, same source of light, source. Okay, it is emitting the frequency of light. Person is here now. Okay, इसका lambda देखो. Actually, just imagine that the source of light which is approaching towards the observer, moving towards the observer. When it is moving towards the observer, no, the wavelength क्या हो रहा है, decrease हो रहा है. It is emitting the frequency that is new, original frequency, but it is approaching towards the man, no, that's why he is observing some other frequency. Correct now. This condition, white light is coming, but he will receive the blue in color. Blue color का light observe करता है. Correct now. This is blue color one, right? We call this one as a blue shift. ठीक है ना. I hope you guys understood that what is blue shift and as well as what is red shift. Red shift होने के लिए क्या होना चाहिए, wavelength बड़ा होना चाहिए. Blue shift के लिए wavelength छोटा होना चाहिए. Correct now. So wavelength छोटा होना चाहिए means the source of light or a observer should be moved towards it. Blue color के लिए, right? Red color के लिए it should be moved away from each other. Clear है ना? Okay. How to calculate these values? That is also coming to the point. Correct? Okay. देखो इधर कैसे कैलकुलेट करते हैं. पहले वाला सोर्स ऑफ लाइट का, सोर्स ऑफ लाइट के पास source which is emitting the wavelength, it is new, frequency of new. Person which is observing the frequency new dash, I don't know. Okay, इधर क्या हो रहा है, frequency change हो रहा है. Correct ना. This change in frequency with the original frequency, either we are going to relating this one with relative velocity minus, we are going to call this one as v radial. V radial means it is nothing but relative velocity. Relative velocity of, if you suppose source which is moving towards the observer means observer is in rest, with respect to the observer we are going to say the velocity of the source, okay, divided by speed of light, right? This is the equation which we are going to use to find out the value of change in frequency, और frequency कितना emit हो रहा है और कितना velocity से move हो रहा है. All things we are going to find out from this equation. Okay. Okay. What if in case they are asking about they are asking in terms of lambda means, है ना? We know nu is equal to c by lambda. C का वैल्यू कैसे दिखता है? C is equal to nu lambda. Means here nu changes means lambda also changes. That's why we can write this one as like this. Delta lambda divided by lambda is equal to V. Just a minute. V radial. Radial means relative velocity. V radial divided by C. This is in terms of lambda. Correct now? It's a fractional change in frequency and as well as fractional change in wavelength. ये दोनों को क्या कहते हैं हम? Fractional change in frequency or wavelength. Right? Still you have any doubt? Please drop your doubt in a chat box, guys. If you have any doubt means. Okay, cool. If you don't have a doubt means no problem. Let's move towards next one. Yeah, we'll discuss on numerical problem based on this one. Then it might be given good idea about it. Okay, correct है ना? Okay, सुनो, इधर एक स्टार है. ये क्या है? स्टार. चैलेंजिंग स्टार, सुपरस्टार, क्रेजी स्टार नहीं है, ये स्टार है. हमारे यूनिवर्स का एक स्टार. इट एमिटिंग इट्स ओन लाइट. ओके, मान लो स्टार इमिटिंग द वेवलेंथ. वेवलेंथ है ना स्टार का, वो है 6000 एंगस्ट्रॉम. ओके, इधर एक पर्सन खड़ा हुआ है. किधर? धरती माता का पास. I'm the person standing here. I'm looking this star actually. स्टार से इमिट हो रहा है ना, तो वेवलेंथ है 6000 एंगस्ट्रॉम. ओके, एक्चुअली दिस स्टार इज मूविंग अवे फ्रॉम अस. क्या हो रहा है? इट इज मूविंग अवे फ्रॉम दी our view. Okay, it is moving rate is 5 kilometer per hour. Okay, 5 kilometer per hour में मूव हो रहा है. Right now it is moving away means what kind of a shift is it taking place? What kind of a shift is it for? Let me know. First question is what kind of shift is this one? Is it red shift or blue shift? Second क्या है? Second calculate करो fractional change in frequency. Fractional lambda calculate करो. Fractional change in wavelength. ये दोनों को कैलकुलेट करो. Okay, I will give you 5 minutes time, not 5 minutes, 2 minutes of time. Try to calculate this one very soon as possible as. Okay, then I will solve and I will explain how to solve this one. Calculate कर रहा है क्या? Okay, what kind of a shift is this one actually? When it is moving away means, guys, when it is moving away means this wavelength क्या होता है? बहुत ज्यादा होता है. करेक्ट ना? wavelength क्या होता है? Increase होता है. Wavelength increases means person who is standing here, you might be observed that wavelength will be red in color. मीन्स कौन सा शिफ्ट हो रहा है, रेड शिफ्ट। ओके, रेड शिफ्ट हो रहा है मीन्स वेवलेंथ चेंज हो रहा है। मीन्स पहले कितना था एंड कितना शिफ्ट हो गया, मीन्स कितना चेंज हो, मीन्स कंपेयर टू दिस वन, how much amount of it is changing. It's a small amount of change will be occur. How much we need to calculate. कैलकुलेट करने के लिए हमारे पास एक स्टैंडर्ड इक्वेशन है। कौन सा है स्टैंडर्ड इक्वेशन, फ्रैक्शनल चेंज इन वेवलेंथ बाय means change in wavelength by original wavelength. It's a fractional change in wavelength will be equal to minus b radial by speed of light. Guys, इधर देखो, सिंपल का तरीका बोल दूंगा। If object which is moving away from you means object is moving away from you means take v as an positive. When object or source which is moving away, take minute, this source moving away, okay, correct है ना? When source, take v as a negative, okay, when source moving towards the observer. Actually मेरा बैटरी खत्म हो रहा है, don't know guys, I'm going to take this class for a long time or not, maximum 5 minutes चलता है, okay, correct. Take this values here, first change in wavelength calculate करना है, delta lambda is equal to, take this lambda right hand side, minus v, it is moving away, take it minus only, no worries, v radial into lambda divided by c means 3 into 10 to the power of 8 meter per second. v radial का वैल्यू कितना था, 5 किलोमीटर पर हवर into lambda 6000 angstrom means 10 to the power of minus 10 divided by डिनोमीटर में 3 into 10 to the power of 8 मीटर पर सेकेंड। ये 5 किलोमीटर पर आवर है ना, पर आवर नहीं, इट इज पर सेकेंड, टेक पर सेकेंड, ओके। इसको कैलकुलेट कर दो मीटर के, मींस 5 किलोमीटर क्या होता है, 5000 मीटर्स होता है, ओके। आफ्टर कैलकुलेटिंग दिस वन, डेल्टा वैल्यू विल बिकम अराउंड एग्जैक्टली 10 to the power minus 10 angstrom आता है, means it is nothing but 1 into 10 to the power of minus 10 angstrom. इतना चेंज हो रहा है, just 1 angstrom change हो रहा है. That's why when a source of light means star will be moving away from us means you can't able to predict that is a red color. Right now only 1 angstrom it is changing. देखो आ रहा है 6000 angstrom. 6000 angstrom में just 1 angstrom is changing means you can't able to predict. So it's a 10 to the power minus 10 meter. Sorry, correct now. It's very minute amount. Correct now. That's why you can't able to predict that red color or blue color through your naked eye. Clear है ना? Yes. मेरा बैटरी खत्म हो गया guys. I'm going to ending this session at this point only. Okay, we're going to meet you in our next class. Thank you for attending the class guys. Okay, thank you. Okay, battery खत्म हो गया. We'll meet in the next class. Okay, bye bye.